Today's mind-blowing question comes from one of you. How if every person pointed a laser at the moon? Imagine stepping outside one night and instead of the quiet glow of the full moon, you see something weird happening. Across the world, millions, no, billions, of people are pointing tiny red dots into the sky. From every city, every village, every backyard barbecue, little laser beams are shooting upward like a global light show. The question is, if every single person on Earth pointed a laser at the moon, would we actually change the way it looks? Could we light it up, burn it, or even knock it out of orbit? Well, let's find out. The first thing you'd notice is nothing. Yep. Sorry to disappoint, but if you ran outside with your $5 red laser pointer and aimed at the moon, you'd never see the dot. The moon is about 384,000 kilometers away, and that tiny beam of light spreads out the further it travels. By the time your laser gets there, that once neat little dot could be the size of several kilometers across. Imagine drawing with a crayon on a piece of paper, then backing up until you're on the other side of a football field. That's how fuzzy and faint it becomes. So on your own, your laser isn't doing much. But this isn't just you. This is everyone. And that's where things get wild. There are about 8 billion of us on the planet. If everyone had a laser, even a weak one, suddenly we're not talking about a single dot anymore. We're talking about billions of beams of light focusing on one poor moon. Think about a stadium during a concert when the crowd waves glow sticks. One isn't impressive. A million together? It looks like a sea of neon. So, could the moon suddenly light up in a dazzling red glow? Almost like a cosmic stoplight? Here's where it gets tricky. The moon is bright. Really bright. It reflects sunlight back to us, which is why we can see it so clearly at night. Your little red laser is nothing compared to the sun's rays. In fact, the moon reflects about 100 billion times more sunlight than the light from your average laser pointer. That's like trying to outshine a lighthouse with a birthday candle. Even with 8 billion candles, it's not going to compete with the sun. So, the moon won't suddenly turn into a red disco ball in the sky. It would look basically the same. But that's just the beginning, because there are other kinds of lasers. What if instead of cheap pointers, everyone had a serious high-powered green laser? The kind astronomers use to point out constellations. Or even stronger, the kind you absolutely shouldn't be pointing at airplanes. Would that change things? Each of those is far brighter than your dollar store laser, and green light is actually more visible to the human eye than red. If billions of those were aimed at the moon, astronomers estimate it might just barely be detectable from Earth. Not as a crisp glowing spot, but as a faint shimmer of green superimposed on the moon's surface. Imagine looking at the moon and thinking, it's got a strange glow tonight. It wouldn't be obvious to everyone, but sensitive telescopes and cameras might pick up the difference. But let's push it even further because that's where this gets really fun. What if all those lasers weren't just pointers but military-grade beams? The kind designed to burn through metal. Now we're cooking, literally. Could we scorch the moon? Let's do some math. A typical military laser might have a power of 100 kilowatts. That's about the same as running 100 microwaves at once, but instead of heating leftover pizza, you're blasting that energy in a straight beam. Now multiply that by 8 billion people. Suddenly, you've got about 800 trillion watts of laser power pointed at the moon. That's an absurd number, right? Well, here's the twist. The sun is already delivering 400 quadrillion watts to the moon at any given time. That's hundreds of thousands of times more power than our combined laser army. Even if humanity fired everything we had, the moon would just shrug and keep shining. Our lasers would add less heat than a mosquito landing on a campfire. So no, we're not melting the moon. We're not cracking it open like an egg. We're not turning it into a glowing red marble. At best, with insanely powerful lasers, we might carve the tiniest of tiny scorch marks on the lunar soil. And even then, we'd need to keep firing for hours, maybe days, to leave any trace at all. The moon has been bombarded by asteroids for billions of years, and our little laser show wouldn't even make it flinch. Still, the idea of 8 billion synchronized laser beams isn't entirely useless. In fact, scientists already use lasers to measure the distance to the moon, thanks to reflectors left behind by Apollo astronauts. They fire superfocused beams at those reflectors, then measure how long it takes the light to bounce back. This helps confirm the moon is drifting about 3.8 centimeters farther away from us each year. But that's just one beam. Imagine billions. We could, in theory, create the biggest science experiment ever. Mapping the moon's surface in microscopic detail, checking for tiny movements, or even signaling to anyone who might be watching from afar. And here's where it gets weird. What if someone was watching? From another planet, say with a telescope, they might suddenly see Earth light up the moon with a coordinated flash. To them it would look like a global signal. Almost like we were trying to write, "hello," in giant letters across the lunar surface. It might be the most visible act of planetary teamwork we've ever done. But before you get too excited about signaling aliens, here's a twist. Our lasers could backfire. Not on the moon but on Earth. With billions of beams crisscrossing the atmosphere, some of that light would scatter. Air molecules, dust and water vapor would bounce it around, lighting up the sky in eerie ways. Pilots would see blinding streaks. Satellites might get hit. And the sheer energy of so many beams could actually warm the upper atmosphere slightly, not enough to cook us but enough to mess with measurements or even blind delicate space telescopes. In trying to light up the moon, we might just make a mess for ourselves. If we actually manage to synchronize it perfectly. One moment the world is dark and then suddenly billions of beams erupt into the sky, converging on the moon like a cosmic flashlight. From Earth, maybe you'd only see a faint shimmer, but if you could stand on the lunar surface and look back, the view would be terrifyingly beautiful. Picture the Earth glowing with billions of red and green pinpricks, all aimed at you. It would be the brightest, strangest night of your life. Now here's a crazy thought. Could all that pressure from photons actually push the moon? After all, light carries momentum. Solar sails work on this principle. Photons push against giant reflective sheets in space, providing a tiny but constant thrust. So if 8 billion lasers were firing at the moon, wouldn't they give it a shove? The short answer: yes, but the effect is ridiculously small. The moon weighs about 73 sextillion kilograms. That's a 73 with 21 zeros after it. Your laser pointer's push is roughly equal to the weight of a single bacterium resting on your hand. Multiply by billions of lasers and it's still basically nothing. The moon isn't going anywhere. But what if instead of a one-time stunt, we did it every night? Billions of synchronized lasers for weeks, months, even years? Well, our atmosphere might start noticing before the moon does. Continuous high-powered beams would heat the air along their paths, creating shimmering channels of ionized gas. Imagine artificial auroras blooming over every city. Airplanes couldn't safely fly. Satellites looking down would see Earth glowing like a Christmas ornament. Ironically, the side effect of our lunar laser obsession would be transforming our own sky, not the moon. And then comes another twist. What if we didn't all aim at the same point? Suppose humanity decided to trace shapes across the moon's surface. Coordinated groups in different countries could draw massive glowing symbols visible from Earth. Want to prank the next generation of astronomers? Just outline a giant smiley face on the Sea of Tranquility. Or imagine governments competing to brand the moon with corporate logos. The ultimate advertising space, sponsored by 8 billion laser beams. It's ridiculous, but also technically possible, at least for short bursts. There's another, more sobering angle though. Lasers, especially powerful ones, are dangerous on Earth. Billions of high-powered beams crisscrossing the night sky would blind animals, disrupt nocturnal ecosystems, and disorient birds that navigate by the moon and stars. Migratory patterns could collapse. Imagine entire species getting lost because their night sky was hijacked by a global laser rave. We'd be altering Earth's biology in ways far more dramatic than the faint glow we'd ever produce on the moon. And then there's us. If you've ever had someone shine a laser in your eye, you know it's not fun. Now imagine stray beams from across the street, across the country, or even reflections from satellites. Human eyesight could be permanently damaged on a massive scale. Cities might need new laws, new shielding, or even laser-free zones. The attempt to make the moon glow could turn into a global safety hazard. But let's say, for argument's sake, we solve those issues. Humanity agrees to build the ultimate coordinated laser system, safe and controlled, to send a clear message to space. Could we use the moon as a giant billboard for the galaxy? Surprisingly, yes. If billions of lasers were carefully modulated, pulsing in sync, we could spell out signals in Morse code across the lunar surface. To anyone watching with a telescope from another star, the moon might flicker unnaturally, screaming, "We're here." It would be the biggest, brightest interstellar postcard in history. But here's the question: do we want to do that? Broadcasting our presence to the universe isn't without risk. What if the neighbors aren't friendly? What if our giant laser hello is interpreted as a challenge? Suddenly, our fun science experiment takes on a darker edge. Maybe, just maybe, there's a reason we haven't seen other planets doing flashy laser tricks. Maybe silence is safer. And still, the most fascinating part is how something so seemingly powerful, billions of people working together, barely registers against the raw scale of space. The moon doesn't care about our lasers. It's endured asteroid strikes, solar storms, and cosmic radiation for billions of years. Our combined light show, as impressive as it feels to us, is just a whisper compared to the roar of the universe. So what's the takeaway? If everyone on Earth pointed a laser at the moon wouldn't melt or break or suddenly glow like a traffic light. At best, we'd produce a faint shimmer, maybe even a detectable green glow under the right conditions. At worst, we'd blind ourselves, confuse wildlife, and turn our skies into chaotic laser soup. The real action wouldn't be happening 384,000 kilometers away, but right here at home. And yet, there's something beautiful in the thought. Billions of humans, for once, doing the same thing at the same time, focused on the same goal. Even if the science says it wouldn't change much, the symbolism is powerful. 8 billion tiny lights, combining into one global gesture, reminding us how small we are and how big the universe is. Maybe the real lesson of the laser moon experiment isn't what it would do to the moon, but what it says about us. So next time you see that quiet glowing disk in the night sky, think about it. What if we really could come together like that? What if 8 billion people could point their energy, not just their lasers, towards solving something bigger, like climate change or space exploration, or making sure future generations can look up and still see the moon shining back at them? That would be brighter than any beam of light we could ever shine. If you enjoyed this wild thought experiment, let me know what if scenario you'd like to see next. And hey, don't forget to subscribe because the next one might just be even stranger.